Okay, welcome everyone to part 2. So we saw last time how using actually relatively simple code when it came to it, we used the polyfit function to separate out the linear component. We then did a 12-month smooth and we removed those two. Okay, so now let's focus on looking at the seasonal cycle. We'll go into a little bit more detail to look at the kind of properties of the seasonal cycle around the coast of Australia. So I'm going to create this control 2. Again, we can just kind of cut and paste code here and edit it. Okay, so again, my name, my date. So this M file here analyzes the seasonal component. Now I'm going to leave the SID in the top because that's what I want to call. So my first step is I'm going to be loading in the data. So actually here I can just use the load function and I can use the same file name here. I could put file in if I wanted to, but let's just shorten it and do it like that. So it's that simple. I'm just going to load in that mat file that I created. So I've got the wrong one here. Go down to the bottom and it's this one here that I want to load in. The output file I created previously. So I want to load in mat file, the SID, and then the mat. And again, the reason why I use the SID here is later on we can do this for any site. So now you can see I've just loaded in those variables that I want. Okay, now I'm going to calculate the kind of mean seasonal cycle. So let's calculate the mean monthly mean sea level cycle. Again, do a separate block of code so we can kind of run these sections. Okay, first of all, I'm going to find the length of the seasonal mean sea level cycle. I can already see it down here. It's because I can get it from here, but it's 1478. And then what I'm going to do is, at the moment, this is just a long line of data, but what I want to do is reshape it so that each row is a year and each column is a month. So I kind of reshape this matrices. So how do you think you might reshape? Well, actually, you can use the reshape function. So again, with MATLAB, you know, the keywords are quite key. So with this, I put in the seasonal mean sea level, and I want to reshape it into 12 rows, and then the number of columns is going to be the length divided by 12, and they're going to prime it at the end, which just inverts the matrices. It just changes the rows and the columns around. So what I now do is I have this month, and you can see there's 123 years. I'm going from 1897 to 2019 or 2020, I can't remember which. And there's now, so that's January of the first year, February, March, April, May, through to December. And then you've got your second year. And you just want to check that this is the right way round. Yep, it's put in this way. Okay, so now we have the data in a shape that we can easily manipulate. And what's really nice with the MATLAB functions is they work down each column. So what I'm going to do is put a variable called mm. And now I can use a function called nanmean. I don't use mean because it won't use it, but nanmean just ignores any ends. And I can take a mean of m. And what it does is it takes a mean of each row. So that's the mean of January for all years, mean of February for all years. And I'm just going to set up another variable called month, just for plotting purposes. And this just goes from 1 to 12. So now I have and this is the mean of all Januaries, all Februaries, all Marches, and we'll plot that in a minute. Okay, so now we can bring in a figure. Or plot. Just get into the good habit of always labeling things. So we're going to bring, now I'm going to cheat, and again I'm just going to copy in a figure from previously. Okay, so we're going to bring in a figure, and now I'm just going to have one subplot. I still quite like doing this because in fact we don't even need a subplot if you don't want to. Okay, so now I'm going to plot to start with all of the months, so M. And I'm going to put this as line width 1, and I'm going to put the color as grey. And grey is just 50% red, 50% green, 50% blue. If we So let's put in an X and a Y label. So again, it's millimeters. The X label is years. The title is, let's see, it's just mean sea level, the seasonal cycle, or something like that. I'm just going to, for the time being, so the X limit is actually going to go from 1 to 12. So let's run that to start with. So here I haven't defined an axis, but I can use this GCA, which just stands for get current axis. It's the same thing. So there you can see really nicely, that's the seasonal cycle, and each grey line is a different year. But what we can do here is plot the mean one that we calculated on top. I'm going to plot it as 2 as a red. So there you can see that's the mean seasonal cycle. So you can see it kind of peaks in June, it troughs in October. You can see really clearly now all of the years, they vary a little bit, but most of the years have that kind of same cycle. Now down the bottom here, I actually, well, first of all, I should change that to month. But what I'm going to do is I'm going to set up another variable called month label. And here I can use these funny squiggly brackets. And I'm going to do 6 and then cut and paste, but I'm going to put in just a letter for the months. So January, February, March, April, May, June, July, August, September, October, November, and December. And this is a little trick, but again, once you get good at MATLAB, there's nothing you can't change. So I'm going to put an X tick. I'm going to make sure my X tick goes from 1 to 12. So there's going to be a tick every one, and then I can set the X tick label property, and this label now is going to be this thing that I created earlier, MOL. So now when I pull up this, you can see it's got those months down the bottom, which is really nice there. Okay, now I'm going to do just a final bit of code. In fact, let's leave that figure up because I think I need it in a minute. Now my final bit of code, step 4, is going to calculate the amplitude and phase of the seasonal cycle. So I want to calculate how big it is. I can estimate it from here. It's about 150, maybe 200, but let's calculate it exactly. Okay, so I can use that. First of all, let's do the max and minimum. So again, it's square brackets, the function name in brackets, and there's a function called, well, let's start with max. So here I'm going to say the function is m understroke max, and I'm just going to put an I, and that tells me the row number when there is a maximum, and I want to take the max of m, and then I want to do the same min and j, the minimum. And let's just switch this off so it writes it to the screen. So have I done the right one? No, sorry, I need it to be not m but mm, because that's my, so let's just clear the screen and run that again. Okay, so the minimum is month 10, which is right. The maximum is month 6, and it's 131. Yep. Okay, so now we can work out what the range is. So the range, let's just call R, is the maximum minus the minimum. We can print that to screen if we want. I've called it main, so again you have to be a bit careful. So it's 214, so the amplitude of this is 20 centimeters, 214 millimeters. And if we want, we can store this into just a single variable, so we could export this and look at this later. So row 1, column 1, I'm going to put in the month. So let's put in I, month I, which will be, in this case, it will be 6 for the maximum. Then we can put in the month J, the month when it's the minimum, into row 2. And then rows 3 and 4, we can put in the actual max and minimum values. You can store this however you want, really, but I'll store it like this way. So now I should have a variable called O, which just contains, so it's 6 and 10, and you can see the maximum and minimum there. I think let me change that to D, because I think I called it D in the step-by-step guide. Now we can plot this. So we can plot D row 1 against D row 2. So sorry, I've messed up here. This should be row 2. This should be, it's better to lay it out this way. So you'll see in a second when I run this. So let's clear D. So it's going to be row 1, column 1. I think this will make more sense. Sorry, I've got a bit confused there. Let's run that code all again. Now if we go back to, let's open D. Yeah, sorry, that makes more sense. So we have the month and then the maximum value, the month, the minimum, and then the maximum value. So now what we can do is we can just plot D1 against D2 as a blue circle. I can make the line width of that 2. So now when we run this, you can see it's plotted those on there. Now again, look at the step-by-step guide and you can compare this with the strength of the Lewin current, and what you find is that the Lewin current does tend to be maximum in kind of May and June, and weakest in sort of September, October, which ties in quite nicely. So there you've done a simple analysis of the seasonal cycle. I'll stop the video there and then we'll do the interannual and longer term component one in a minute.